Okay. Good evening, everyone. We're going to start the lecture now. Excuse me. Okay, we're going to start the lecture now. So as usual, I'm using Z-Things for the slide decks. If you want to follow, this is the link. Let's get going. So today, I'm going to talk about big data processes and management. So this course is about big data management. So here I'm going to give you some background in terms of what are the things you need to consider when designing your big data management strategy. What are the pitfalls when you're doing that? What are the things that you need to be aware of from policy side as well? How you can mitigate any issues that can happen in the future. So it's more, for today, it's more of a strategical point of view, so less of technical than you might wish it to be. Okay, so in terms of big data lifecycle, last lecture, like last week, we talked about the data challenges. What are the V's for big data? Volume, variety, veracity, and other V's, visibility. So we looked at it from data concerns. What are the things that make big data what it is? Why the concern? What's the difference from the normal, like the usual data in RDMS file databases? What's happened that made people think, okay, we need to take things up a notch so that we can be able to process this huge amount fast data and in different formats. So we looked at it from data perspective. Today we're going to look at it from process perspective and from management challenges perspective. So let's start with the process side. What are the process challenges? So in terms of the big data processes, so there are two sides for this. The data management side. So there are processes that relate to data management, how you acquire that data, how you ingest it, how you record it and store it, that side. Extraction of the important information from the data. What are the things that you want to extract? How you can make sure that the data you're extracting, the data you're storing is useful. There are not much noise in that data, because noise at some point will make you make bad decisions, will make you provide wrong insights. So you need to make sure that your data is clean. So data cleaning is important. And also annotation in terms of, okay, how you can provide some metadata for the data that you have. So in terms of, okay, there is a post, who posted, at what time. So annotating that data will provide this important metadata that you can use for acquiring additional insights. And after that, how you can integrate data from multiple sources. So this is also one of the points that add value for the data. So data from single source definitely is useful, but once you're combining multiple sources and integrating that data, linking this information from different sources and linking that to some single data instance or specific incident or specific event, that make it add more value for your data. Aggregation, similarly, when you aggregate data about specific instance of data, that's information that you're gathering from multiple sources, all provide you this wholesome view of what's happening or what's the event that you're after. And definitely, like once you have your data and it's nice and clean, you accumulate data from multiple sources, you integrate it so that it can provide better insights. Then how you can represent that, how you can report on that data, providing the information that can help decision makers or analytical systems to consume this data in order to do some prediction or do some clustering to identify some outliers. So representing that data is also key in the big data management aspect. And after that, like when you're having your data and it is presented properly and you can, analytical systems can consume that data, you think of analytics, what kind of analytics you can apply. So how you can model any analytics algorithm that can help you extract useful insights from your data, analyze that data to get something that you are after, either to discover something or to prove or disapprove something that you have. And interpretation of all this analytics in terms of, okay, what's the final decision? Should we buy that product? Should we sell? Should we stop that experiment? So interpretation of that on, like let's say, human side, also to be able for people to consume it is also important from analytics, because applying analytics doesn't make much sense if there is no interpretation at the end providing that, okay, this is the final decision, we should buy more stock, we should sell. So let's start from the beginning for data acquisition. So usually like that depends on, definitely on the industry, on the, like what's the data you're dealing with. So if it is something that's coming from sensors, so you're acquiring some sensor data from machines, from environment. So it's coming from the physical system, and then you're trying to digitize it and allow it to be in a digitized form so that any information system can digest that. So the samples from physical system, how you can record these occurrences, how you can record these sensory data. Probably it is, in terms of sensors, might be analog data. How you can digitize that is also one of the points that you need to consider when acquiring the data. So in that sense, because unless you have it somehow that you can process it, you can reason about it in your information system, then it is useless for you. You cannot argue about it in terms of analog readings. That's going to be you're not going to be able to process or analyze later on. So possible ways of like things that can provide this sensory data, even your smartphones. So your smartphones are constantly recording your movements, messages you're sent, like your geolocation, anything like how many calls you make, how many messages you send, how many messages you receive. All this information your mobile phone is collecting about you every second. Things like social media, acquiring all the information, that any content you create, you tweet, you post a photo, all these informations are provided by this sensory data that's coming from the real world. So you make a post, you are talking to your friends, but that post is read by people and they start to interact with that post. They like it, they comment on it. So all these interactions are digitized and you can acquire it in order to do some processing and draw some insights. Similarly for IoT devices, online retail systems, all these are interactions you're doing on the physical world. You're trying to buy something, and then all the information going through any system that you're using, whether eBay or any other platform, you are doing the transaction and it is recording like the purchase you're doing, and then what's happening when it is delivered, when it is arriving, and stuff like that. So the sources of this data, user generated, so people post, tweet, take photos. So in that sense, it is mostly unstructured data. So there is no, like when you're taking a video, you're posting a video, or you're posting a tweet. In that sense, it's unstructured. There is no specific structure in the data you're creating. It's up to any system that's consuming that to determine how to make use of, okay, is there some tagging system for that photo to say this is a photo of a location or this is a photo of an object or something like that. So because it's unstructured data, it's more challenging, and it is raw in terms of, okay, other than sometimes people either they tag the photo themselves or they allow geolocating to be tagged within the photo. Otherwise, there are sometimes like the photo you are posting, it doesn't have some useful metadata. So other than that, you need to either integrate information from different sources to make it more useful, or sometimes it's available within the data itself. Transactional data, like there are a lot of systems providing transactional data in terms of banks, the information that you generate when you log into any system or you're using the web. All these information are transactional data. So you're doing something and there is a transaction, you're doing a request, there is a reply. All this information is more structured, but it's also recorded for specific companies. Like for banks, they record every transaction you're making so that at the end they can know that with all their customers, what are they, is there any movement toward money withdrawal in this month? Is there any movement that a lot of people are taking loans? Should we advertise our product more in this term? So all this information banks gather, transactional information, so that it can help them generate insights. So it is, with the transactional, it is typically structured because there is a system controlling this. You are trying to do the transaction, you're withdrawing, there is credit and debit. So it's more structured, so predefined in a way. Scientific data is also one of the things, because this is specifically like the start of relying on big data also comes from scientific area, because a lot of experiments generated lots of data, and then this kinds of data come from different formats, whether it's structured, unstructured, sensory data, or like genome data. So all this information also, in terms, you need to either reason about, okay, what kind of information I'm getting, how can I treat them, is it structured, is it semi-structured or unstructured, how can I process that? Yeah, so other examples, web data I mentioned in terms of like even the website themselves, when you crawl them, this is also raw data. So crawling the websites provide you with information of the website itself, what's being offered, what's being presented. It depends on who developed that website. It can be structured, semi-structured on some way, depending on how they design that website. And graphs, just like for social media, when there are entities connected together, there is the graph presentation for all the entities and the relationships. So this is also a source of information for that. So now, like there are different kinds of data coming from different sources. They are in different formats, structured, unstructured. So the first thing, after like thinking, okay, how can I manage getting that data, acquiring that data, digitizing it properly so that it can be useful for me? Because not all the time you think about, okay, I store all the photos, but then for you, as like if your system is not going to do some image processing, then that might be not very useful for you. So you might think of, okay, there are some photos, but what's useful for me is the metadata about these photos. So I'm interested in when this photo was taken, where this photo was taken, and who was tagged in that photo. So sometimes, like for the data itself, it's not very useful for you as the image itself, but more the metadata surrounding that is useful. You can generate, depending on the service you're thinking of. So whether it is the artifact itself, the photos, or whether it is the metadata, after acquiring that, you need to think of, okay, this huge amount of data, how can I store it? You need to store it somewhere so that you be able to analyze it, clean it, analyze it, and then draw some insight from that. So there are different technologies for storage. The traditional ones is relational databases, with as an example, MySQL. We're used to that. We store data in relational databases. It's reliable. It's somehow well supported, so I know how to use it. There are a lot of resources in that regard. So relational databases are useful as a storage, but at some point for big data, it's not gonna cut it for the point of, okay, do they provide fault tolerance in terms of distributed computing? So there are some instances for relational databases, relational database management systems in specific, that offer parallel solutions. So they are going to provide you solution that can segregate your data into more machines, and then you can parallelly make an inquiry for these machines. So they try to break through into the parallel processing area. But the problem with some of these solutions is that they don't offer fault tolerance. So at some point is like, okay, I am providing you these separated data instances or data storage, but at some point, if one of them is down, then you need to load a new database with the data in order to be up to a working condition. So relational database management systems are useful in some cases, but with big data, they are a bit restrictive. So things like NoSQL databases came to the rise in terms of, okay, what they are offer is more horizontal expansion for that. So you can increase the number of, distribute the number of data instances on more machines, and which is, you can, with some technologies, cater for fault tolerance, and hence overcome the issue of, okay, parallel versus fault tolerance. So some of these technologies like HBase rely on distributed file system, like HDFS, which is Hadoop filing system. So in that sense, it's because you need to also differentiate between, okay, a database management system versus a file system. So file system like HDFS can provide you with the capability of distributed storage of files on like more machines, commodity machines. But you still need some sort of data like database management system in order to cater the capabilities that you are more accustomed with, just like with the relational databases. So using HBase on top of HDFS can prove useful in that sense. You're still getting distributed computing, fault tolerance, which is the features of Hadoop, but still also have some capabilities to reason about your data in big tables, because HBase is more big table-like system. There is also other data storage technologies for graph databases, like depending on your application, like for Facebook, storing the data in a graph-like database make more sense for them because they rely on entities, people, posts, and their relationship between them. So relying on graph databases make more sense in that instance. So like this is the capability, the technology that you use for storing your data, but still you also need to determine, and according to that, what's the type of data that you're storing. So is it a key value pair? So in terms of, okay, are you storing a document, key value document, just like for MongoDB? Or are you relying on something, is it more in a relational format? So you need some tabular formats for things like HBase to rely on. So you have your tabular data, and then you're storing it in HBase, which make more sense. So depending on what's the type of data, so how the data is represented, you also need to base that in your selection of the solution. What's the data is like, how you're storing the data, what system you can use for that storage. And definitely when you're looking at it, you need to always, since the data storage is closely related to the data itself, so you need to keep at least the 3 V's of big data in mind. So the volume, so how large, how easy for you to expand. This is also one of the key elements of, okay, is it simple for me to scale out for this, or do I need to vertically scale in terms of add more storage units in the same machine? So you need to make sure that, okay, you're catering for velocity, for volume, sorry, and then you're catering for velocity. So in terms of how fast is the read and write operations, how fast the data is coming, and how fast I can load the data in my database management system so that it's still relevant to the application I'm using, and definitely the variety in terms of the data structure itself. So you've acquired your data, you stored your data in some storage facility, and then you're thinking of, okay, I need to extract the useful information from that data. So what are the relevant things that I'm thinking about? So because like data, it can be like if you're collecting information from like social media, there are a lot of things generated by people in social media. Not necessarily all of that information is useful to you. So you need to extract the information that's more relevant. So if you are thinking, okay, emails, should I think about, which is unstructured in this sense, do I need the body of the email itself to extract information that's what they are trying to tell me? Or is it just important for me to know that there is an email going from X to Y at that time, the title is this? So depending on what's the relevant information you're trying to extract, you need to visualize of this, because not always it's important to extract everything. It's costly. Every operation you do on big data is costly. So you need to always think about, okay, is what I'm doing useful, or am I just doing it for the sake of doing it? So things like, okay, on terms of how you are, when you are extracting data, how you are managing data duplication. So within big data, especially if you're extracting information from multiple sources, you need to also keep in mind that there is possibility that data is duplicated from multiple sources. So how you make sure that, okay, this is actually a duplicate and I'm not losing data if I eliminate one of these instances. So there are different techniques in terms of either using pattern recognition. So you're like specifically when we're looking at unstructured data, what are the pattern written in the email? Is it instructional? Are they telling me to do some action? Are they requesting? So what they are trying to do? And using some natural language processing or machine learning techniques can help with the unstructured data to help you acquire the useful information that you're after. Depending also on the type of data you're tackling, also like here in the instance with another example, when you're looking at web data, so you're collecting information from the web. So there are things you need to consider in terms of, okay, what am I extracting from that website? Is it in HTML format? How can I extract the useful information that's relevant to me? So depending on how that website was designed, so if it is in a tree-like structure, you can use some tool for that, like web scraping, and to acquire that information and then store it in your storage. So depending on what the website is like and what are the information, like if you're after a table in the websites, if you are collecting, in the sense, if you're collecting only the transactional data, like how many times that website was accessed. So not necessarily extracting the information of the website itself, but more like you're after something like Google, what's doing with PageRank. What they are doing is that they try to find out how many other websites, how many other resources are linked to this website. So in that sense, they want to determine that, okay, this is a higher rank page because there are others who are referencing this, linking to it, and hence I can put it up when people are searching on my engine. So depending on what kind of information you are after, not necessarily the website content itself, because previously what's Google was doing is that they looked at the contents, and if you're searching keywords that's relevant and someone comes, and this is was the creation of what they call scam scrappers or something like that. So what they did is you create your website, and let's say you're trying to sell shoes, and then you write shoes 1,000 times. And then when the search engine comes and say, oh, this website is saying shoes 1,000 times, that means it's really about shoes. And then it put that on the top of the rank, saying that this is the best site for shoes because the content says shoes 1,000 times. Google noticed that this happening, and that's why they changed toward more PageRank approach. So they are more like, okay, who are other websites linking to that site? And hence, if the more websites link saying that, okay, yes, this site sells shoes, yes, it's a very good website providing bargain deals, blah, blah, blah. So the more websites linking to this website, the more it's bring it up in the search. And hence, it was more realistic than looking at the content themselves and making the decision. So pay attention to this in terms, this is an example that it's not always about the content. Sometimes it's about more the metadata, how many other sites linked to something, or how many times that it was accessed, what times, when, things like that. So you've extracted your data now. This is the bits, that's important bits that I'm after. You need to also look at the points of cleaning that data. Sometimes data is important, but unless it is useful data in terms of not only the usefulness of what's your use case, but also in terms of whether that data is clean, that it's usable. So it's useless for you to use something that have a lot of errors, because if, let's say, on sensory data use case. So if you have a sensor and you're acquiring data from that sensor, and that sensor is telling you that for 80%, or not necessarily 80, even 20% of the time, the temperature is 0 Celsius. But you know for a fact that that's impossible because it's summer. So you say, okay, probably that's giving me some bad readings. So looking at this, making sure that, okay, according to the use case, okay, is this reading realistic in terms of the environment, in terms of the setup, in terms of what's the use case that you're looking at? You need to make sure that how you can keep the meaningful reading, how you can preserve that in terms of discarding the noise or the useless reading. So data quality comes in different ways. So there is completeness of data. So if it is telling you something, and then let's say there is a sensor that's, let's say for an image, in this case. So there is an image that's distort part of the, like there is a camera that distort part of the image all the time. So in that sense, it is blocking part of the data that you're trying to acquire. So either you can look at, okay, this is the downside is noise, I can look on the top side, or even take measures that discard the readings from this camera in total, because the data it's provided is not complete. Whether it's like if you're getting some readings from a sensor and it's supposed to be on a timely fashion. So every 5 seconds you should get a reading, and then the sensor what's doing is giving you a reading, but every 20 seconds. So there is 3 time slots in between that's giving you noisy input. So you need to look at this from data perspective. What does it mean to you? Is this a useful source of data, or should you discard it? How you can compensate and stuff like that. So errors, same thing in terms of what's providing. Is this reading realistic or not? Is it relevant to the case? So is it telling you that in summer the temperature is 0 Celsius, or is it telling you the actual temperature of the room? Value, that's also one of the things in terms of what's the data that you're acquiring, what's the data you can use versus the data that's redundant and you can just discard, providing you that if you keep it, it's just going to be costly in terms of storage facilities and processing. So in terms of cleaning, you need to look at data cleaning from 2 areas. So detecting the error. So the first thing you need to make sure, okay, I need to detect if there is something wrong with that data so that I can make a decision later on. So this comes with more error modeling. So just like defining what are the accepted readings versus the unaccepted reading, how you can like either make a threshold or create some template for that in order to make sure that, okay, as much as possible, you automate the detection. Because like we're talking here big data, so it's unrealistic to let someone sit down, hey, sit down here and just tell me if you find something wrong with my data. That approach is not realistic. So you need to, as much as possible, think of automation of error detection. What are the common errors that you've got from the data, and how can you automate detecting these errors? Is it some sort of threshold? Is it some sort of template? Should I cut here, put that there? So depending on the use case, you need to make sure that, okay, if it is a temperature in our case as an example, so realistically, I know that here in Australia, in summer, it doesn't go 0 Celsius, at least in the city. So we say that, okay, if it's coming below that threshold, then discard that information. Above 60 degree, probably also unrealistic. So I will say drop that threshold as well. So you put some kind of threshold in order to automate filtering out the useless reading. Definitely there are, this is like for a simple case of a single number where you can set a threshold, but there are other cases you need more intelligent systems in order to identify if there is some, like, is this realistic? Is it an outlier? Should you consider it or not? So definitely relying on machine learning for this task specifically comes in handy in some areas. So after you detect that error, you need to think of, okay, repairing that error. Is it just discard the reading? Or should you apply something? Is there a possibility that actually my sensor is set up somewhere and it is reading the temperature in Fahrenheit? So while I'm setting it up here to be in Celsius, so I need to do some, let's say, calculation to make things right. So it's not always that the reading is totally useless, but sometimes like measurement are different. you need to compensate. Or in some cases, if you're doing some reading and then you're saying that, okay, I'm going to take a sample every 1 minute, and then you find out that, okay, the sensor is more suitable for sampling every 5 minutes, then you can make this decision of, okay, I'm going to skip this sampling and make 5 minutes, 5 minutes, 5 minutes in order to make sure that the readings are accurate. So doing this error repairing, making a decision or modeling how your system is going to react to this error is important, rather than, because not always, don't think always I need to discard. Cleaning sometimes is, okay, remove the useless data, but sometimes you need to look at what's happened here, how can I repair that data? Should I, if I'm missing readings, should I take 2 readings and average them and put that there? Because some specifically for scientific reasons, the systems are, if you discard the information without making some compensation, that will make your data useless. So you need to look at the use case and then how you can repair the error as much as possible to make sure that you do not render the data useless. So in terms of, okay, so now you have your data, it's nice and clean, but sometimes, as I mentioned a bit ago, that's not all the data itself is important only, but also the metadata, how the information is tagged about something. So like you can think about it, about things like with social media, when you tag someone about a photo or a post, so you create a relation between that person and that event. So you check into a restaurant and then you tag a friend to that event. So in that sense, you have created the relation between your friend, your friend, and the restaurant, and that event of checking into the restaurant. So tagging could be in terms of manual tagging with people drawing a relation or adding some information, or it could be more of automated tagging with information gathered from different sources to do that. Tagging is important, and notation and tagging is important because it provides this enrichment for the data that you can use to generate additional insights. So always think of, okay, do I need to annotate my data with some additional information? With that, make it more valuable. So whether it is possible, whether it is not possible, I'm not saying that it is the case for everything, but in some instances, there is the information that can be useful for, if you annotate the data, it would increase the value. Just like with video tagging, when you tag a video with, okay, just like for the YouTube videos, when you say this is a video, is a tutorial about Java, this. So this help even the search engine when it's looking for this artifact to identify that, okay, these are videos about Java and it is a tutorial video. Things of, even like for text tagging, when there are a huge corpus of text, like most commonly the technology used is like part of speech tagging. So it's trying to find part of speech that translates to something. Is this an action? Is this an entity? What is it like? Is it a mention of someone? So what's this blob of text trying to do? And hence make the translation into annotating this part of the speech as it's an action, or it is mentioning some celebrity or something like that. So annotation techniques differs depending on the situation and depending on the type of data. So there is crowd-based annotation. So this is mostly relying on people to do the annotation, to do the tagging. So just like with Stack Overflow, when you're creating a post and then, or like a question, and then you say this question is about Python and machine learning. So you've created these tags yourself, and then later on someone search or someone is mining Stack Overflow database for give me all the questions about Python and machine learning. They rely on this annotation you have created to pull up all these questions. So this is more crowd-based, people-based tagging. You create the tag, or you annotate the data yourself. On the other hand, there are instances, it's not like this is like something you create. There are other cases when like there are photos taken by people all around the world, and there is a company who wants to tag, okay, is this taken in Sydney, is this taken in Egypt, is this taken in USA? So they rely on crowd forces to do that, so they delegate this task to some service like Amazon Mechanical Turk, which is a crowdsourcing platform. They tell them, okay, we have this much of all these photos. We need some people to tag what the people are doing in these photos. So label them. So here basically what's happening is you're gonna, as a crowd worker, you're gonna pay maybe like 10 cents. Just look at the photo and say beach or city or this. So just annotating what this photo is about, labeling that photo, and you get paid like a small amount. When you annotate like 1,000 photos, then it is worthwhile for you. So Amazon Mechanical Turk is a crowdsourcing platform that helps with this, and companies use that frequently. On the other hand, like when it's come to, okay, no, it's unrealistic for me, it's too costly to rely on crowdsourcing, so I'm gonna try to do some automation. So definitely there are automation techniques using machine learning, so image recognition, video recognition, that can help you with this. Sometimes like you need to invest in the algorithm, but let's say if your bread and butter is about image tagging, then definitely you need to invest in some sort of algorithm that can help you this with, okay, this is in the city, this is in the beach, and this is in the forest. So if your service is about this, definitely it's worthwhile to invest in image recognition techniques. And there is like also the things about hybrid approaches. So sometimes there is, okay, I'm gonna rely on something part crowdsourcing, part machine. So the crowd is helping me either train my algorithm in order to provide some sample training data, and then the algorithm will take that and do it automatically. Or the crowd can filter part and then give it back to the machine, or vice versa. The machine learning algorithm is filtering something, rolling out that, okay, these are all beach photos, these are all forests, but then the crowd is going to more specifically say, yes, this beach is, there is some sign saying that this is Bondi Beach. There is some sign saying this is Coogee Beach or something like that. So hybrid approaches also exist, segregating this, the task of annotation between the crowd and the machine. So once like you have your information tagged and it is labeled, it is now enriched, it is more useful. You think about things of, okay, doesn't make sense, or is it, would it add more value to integrate more information within, like to enrich my data, or like to enhance my data in my repository. So integrating data from multiple sources would be very, would elevate the value of your data greatly. This is like, some argue that this is like the thing that made big data great. Because in the sense, it's not only that you get information from a single source and then you're dealing with it, but more like, okay, it's definitely more valuable to get information from this source, from this source, from this source, integrating them together, linking this information together in order to be able to do some more useful market research or something like that. So getting information from heterogeneous sources would increase the value of your data. So like usually with enterprise data, with data warehouses, things like ETL, the extract, transform, load tools are responsible for this. This is like worked very well for enterprises because for them it was more like, okay, this is for us, it's organizational data from sales, organizational data from billing, organizational data from our third party. And then we can do things like schema matching and then integrate them together. So within an organizational setup within an enterprise, the ETL tools worked fine because relatively it is structured or semi-structured to some level that I can do some schema matching and get information, like increase the value of the information I'm storing and hence getting more insights. But at some point there are some ETL tools for big data, but it's still more into on the, let's say, research level. Although like some of them is commercial, but not as much as the usefulness of what it was in enterprise solutions. So when it comes to integration, the possible ways to do that is the most common way specifically for enterprises was schema matching. So what they were looking is either create this global schema that has the information that the organization is interested in, and then try to map the local schema into this global schema. And hence, after that, query that database and just like your normal relational database. So for enterprises, that work fine. For limited data sources or for semi-structure that you can map to a global schema. With big data, things got more challenging. So new techniques has arisen in terms of record linkage and data fusion. With record linkage, it's an active research area because still there are some approaches, but still the research community is working with that because there are some issues in terms of, okay, duplication or integrity of the data or like confidence of this link. So the principle here is that, okay, from these multiple sources you're getting, I want to make a link between this data instance and the other data instance coming from a different source, and I say, yes, this is about the same person because this and that. So there is some reasoning in that area in terms of, okay, although these two different data sources are not related in a sense, like they are not formally related, but you are creating the link between them in order to enrich your data. So it's still an active research area because there is some issues with the, okay, how do you make sure that this is actually the right person, or it's not a duplicate, or that this is not someone who's like very similar but not identical. So here it's more fruitful if you do it, but at some point it also has some limitations. So you need to make sure that the right tool that you use for this is catering what you're after. And also at some point you need to make sure that, okay, what's the level of confidence they are providing? And for my customer, what's the level of confidence I can promise? Data fusion, on the other hand, is also, it's still in the active research area. What they are trying to do is remove this ambiguity of this information coming, should I link this person to this data instance, or like should I link this data instance to this data instance? So what they are doing is more loading the data together and then trying to map internally if these instances has relations or not. So it's similar to data to record linkage, but rather than on separate level, they try to pool the data together and then draws the similarities and the connection between the data. So it's more like, okay, I'm trying to create the world with these information and then try to reason about, okay, this is the state and this is this person because he's linked to, he tweeted this and it's the same person who have the same email address about in Twitter and in Facebook. So it's more trying to link, pool the data together and then reason about the connections between the data instances. So with aggregation, it's like on the level of when you know that there is a link between the different data instances and then just you're aggregating data from from the sources. So here it's much more, it's on a level easier than integration because you have the knowledge and the information about what's the relation between the data, and then you're just trying to accumulate the information about this data instance from multiple sources, and hence make the enrich your data. So here it's more storage systems for Hadoop can manage that for you, accumulating all the data from multiple sources. But for some point, you need to always make sure that, okay, how you are storing that data and what's the level of information you are providing on a specific instance or a specific incident or event. So things like related to privacy and security come to hand. So if you have your okay, I know all these users and they have their own financial information here, and I'm combining that together. I know that they have purchased this and they have posted that. At some point, for the company, that's useful, but there is a fine line of when are you in breach of privacy, when you have access to more private information, breaching any service level agreement with the user or with the consumer. So aggregation is definitely useful, but there is a fine line of, okay, since you have it separately, that's fine for different users, but when you combine them together, when you triangulate the data, then you have more information about a single person or a single event, then that might not be convenient or might be not acceptable for people. We'll look at that on the security part a little bit further. For the representation, as I mentioned, it's like, okay, you stored your data like here and you extracted, you integrated the data, you enriched the data, but still you need to, okay, the final form that you are gonna process or analyze, you need to make sure, okay, what's the type of data? How do I store it? Is it in a JSON format? Is it in a text? Is it structured? Is it unstructured? Because even this affects what kind of analytics you can use and what kind of information you are after. So making sure that, okay, you define that, okay, all the information I'm collecting, then I'm gonna turn into JSON document and store them, or I'm gonna turn them into a big table and then store them. So you need to make decisions into what work best for your use case and for the analytic tools that you're gonna use in terms of how you can generate the insights. Okay. Okay, so let's take these two slides and then we'll go to a break. So, and now it's more like into the modeling and analytics. So after you finish with the management side, so you get the data, you store the data, you integrate it, you extracted the information, you integrated, and then you prepared it, you presented in a way that can be consumed. Then you can rely on what you can use for analyzing that data. So applying some analytics on the data in order to generate some insights. So depends on the kind of data. So is it numerical data? So do you do histograms? Do you do some measurement? Do you apply some machine learning in order to cluster the data in terms of identifying, grouping that data in a sense, and then identifying outliers? So all these guys who are interested in Avengers movies are also interested in Harry Potter, although that will never happen, but similarly that can happen. So in the sense of how you apply your analytics tool or the analytics algorithm in order to generate that information, depending on the type of the information. So if it's a numerical, you want to draw, like maybe if you're predicting some reading, will the temperature rise in the next week, or will it fall, or what will it do? Then it's more numerical scatter plot kind of thing. Or if you are more into grouping the data or even classifying. So I want to classify which of these data is legitimate transaction versus which are the ones that are fraud transaction. So also using machine learning classification in order to get that. So each of depending on the use case, depending on the type of data, there are different ways of applying some techniques in order to extract the insights that you want to extract from the data. So in terms of after you extracted the information, let's say the example here is grouping people according to product that they have purchased in Amazon. And then I say that if they have 4 people who are aged between 20 and 25 who have purchased these movies, they also were interested with these movies. So in that sense, I grouped people together. I can do some recommendation for the people who fall in the same group and they haven't purchased the other kind of product. So I say, hey, you have purchased these movie series, and then probably you are more interested into buying this other series or this other series by the same director or something. So in that sense, the system can provide recommendation and hence increase the purchase for products in there for the customers. In that sense, this is more the decision provided. So I applied some analytics, I did some grouping, I find out that these guys like this, also like that, and hence the decision is, let me recommend these products for these people. So the interpretation of the analytics is let's say, the climax of the big data analytics. So it is what's generating the final decision or providing the final insights that can be used for making either yes, I will buy this as well, or for an organization, yes, we will sell this share price or something. So interpretation for the analytics in terms of useful, digestible information for the human that they can base to make a decision. So for text, I can read all the feedback from my customer and I make a decision that from all this feedback I have collected, I can deduce that majority of the customers are not happy with our product, and hence we need to do this and this and that. So based on the analytics, with all the feedbacks, doing some sentiment analysis, I say, yes, with the algorithm picked up unsatisfied tone in in these all feedbacks, and then hence let's do a plan to improve. Okay, so these are the big data processes, and for each one, what we get the examples and the things that you need to be aware of when designing your strategy for big data. So for next, we're gonna look at big data management challenges, but let's take a 10-minute break before that. Sorry? And WebCMS, yes, there is a draft for it. After the lecture, I'll upload the final ones, but there is a draft already.
We can find our lecture slides on the website.
So it is on WebCMS. Oh, just a sec. Yeah, I just need to. Come on. Yeah, because they put it inherently as tutors, but it should be students.
To find it.
Yeah. Okay, so it should be visible now. Nice, nice. Yep.
Questions.
Yep.
I'm really passionate about becoming a data scientist someday. I'm quite interested in the data mining and algorithms because but I'd like to ask, what do you think are some of the main skills or like the skill sets that's essential
Yeah.
in that area?
Yes, definitely. So if you are interested to be more a data scientist on an enterprise level, then probably sticking to things like Hadoop ecosystem is essential, because for industry, they don't specifically use Hadoop, but they use variation of Hadoop. So like they either use Hortonworks system, or they use something called Cloudera. So in that sense, but they are all based on Hadoop on some level. So if you master this, that also give you a good head start in that sense. If you're interested on data science, but on a smaller level in terms of, okay, smaller companies, then I would say that for specifically Python and there is a library, some libraries for data science. It's called Pandas, NumPy, and scikit-learn for machine learning. These are very relevant. Like here I can see like for data scientists in the university where they have like a project for their own research, most of the time they go to Python versus libraries like Pandas, NumPy, and scikit-learn, because it's very lightweight and quick. You can quickly spin out a new project. But for industry, I would say they are still with Hadoop. So this is an introductory course, so it can help you setting the foundation for big data. If you are passionate about data mining, there are also data mining specific data mining courses. In UNSW, you can pursue that. Here, we are not going to do data mining, unfortunately, because we don't have time. But here, like, it's more on the management level. So we're going to get familiar with Hadoop ecosystem, with Spark as a stream processing engine. So an Elasticsearch for indexing and querying. But we're not going to go into data mining or machine learning in details, because we're not going to do that. Yeah, that's because like there are other courses doing that, and there is within 10 weeks it's impossible to cover everything properly. So here we are setting the foundation, but if you are passionate about industrial data science, like for organizations, like you can focus on data mining on other courses as well.
Yeah. And what would you rate like what kind of like intensity or foundation would be necessary to
I would say like it depends on the use case, but like for big data, like if you're aim to work with someone like eBay, where they have millions of users, so in that sense, like definitely mastering the distributed computing frameworks is essential, because you're not gonna play with small data sets. Like even you cannot think of a data set that's 1 terabyte. It's much more. So definitely like frameworks like Hadoop becomes very necessary here. And but I will not. So it depends on like also. So SQL, because if you look at it from a smaller company perspective, they use SQL. But if you go like Facebook, what do I use? Then they will tell you, we have our own interpretation of SQL for big data. That's why they have Hive. So it's an SQL-like language for big data on top of Hadoop. And they have Cassandra for that as well. So when it comes to when you have millions of users and they are generating content, then SQL will not cut it. But for companies like here in Sydney, when it comes to smaller companies, which they have like, we have 10,000 users or like 1 million users, SQL is fine. Like relational database are fine with that. And they are even more reliable because what we call the asset properties like automacy and reliability. So they are more like very rigid and more reliable. Hence, like you know that for sure if the transaction do not go, it will not go completely. So people are more comfortable with the relational databases. But when it comes to big data, SQL will be a bit of a headache because managing multiple instances of SQL database, relational database, working in parallel, that's a nightmare in SQL.
So although they are all like data analysis, it's actually they are on different levels.
Yes, definitely. Depending on the size, the speed of data, the tools need to like distributed computing, distributed database systems like Hadoop ecosystem is essential for big data. But for like 1 million user, 2 million user, SQL can manage perfectly. Yeah, and it is more reliable for them at some point also.
And I think those are like big data are generally like the user generated data or like
Yeah, so it's like it becomes like, because also it depends on the rate. Because when it comes to the rate of data, how fast the data is coming, that also becomes an issue. SQL, when you are looking at, okay, if I want to load a database, it will take around 30 minutes if you're loading from scratch. But for Hadoop system, loading might be in like less than 5 minutes. So even loading data becomes essential. So definitely like the size, the speed of the data, how fast it is generated come into place. It's not necessarily also like as I mentioned, like eBay, for them it's hard to use SQL because for them there are millions of users here and there, they are doing purchases, there are a lot of transactional data. Yes, definitely.
And how where can I learn that? Like, before I actually started working like big support like that, how are you able to learn?
So for us, we are going to give you introduction to Hadoop. So we have activities in week 3 or 4 about Hadoop. So we have 3 labs about Hadoop and 2 labs about Spark and 1 lab about Elasticsearch. So it will give you a good start, this course. But also like on the internet, because it's a very good community, you can find lots of tutorials that give you a very good head start. So yeah, because like it's not something small, not proprietary tool, so it's open source. A lot of people putting tutorial, a lot of people writing books. So it's also useful in that sense. Definitely.
Would you say that like in this case, like learning like the big data wouldn't be any really like too useful if you're working in a small firm,
Yes, small firms are not going to be interested in Hadoop kind of implementation, but depends also on their use case. So if they are consuming data from Facebook and they are doing something, so that's also saying, okay, yes, so it depends on what they are doing and what's their bread and butter. But if it is a small company that rely on their own users, probably they will not even come near Hadoop. But if they are consuming data from somewhere else, then Hadoop becomes essential as well.
Do you think that big data would be like a challenge
At some point, yes, because they will be obliged to not only rely on their internal data, they will be obliged to compete with the big guys as well. So at some point, I believe that it will be also an interest for even small firms, but I wouldn't say like everyone, but I would say also the people who want to go one notch higher. Yes, definitely. Okay, no worries, okay. Okay, we're gonna start again. So, excuse me. Okay, so let's start with the data management, big data management challenges. So we looked at challenges from data itself, processes, big data processes, and now we're looking at management challenges. So also like back to the data lifecycle, so we covered the data challenges, the V's, the process challenges from acquisition to integration to presentation, analytics, and now we are here in the management side. So we're going to go one by one for the challenges for the management side. So like this is the thing is when it comes to big data. So we always see opportunities. Where are you? Okay, much better. So we always see opportunities when it comes to big data. So we say, okay, yes, I can use this. I can get information about these people. I can recommend that. I can. So big data always sounds opportunities. But there are some things that we need to pay attention to in terms of big data that can be like more like the pitfall, not the pitfalls, but more like the challenges that you need to tackle, address, make sure that you do not go in trouble because of you didn't respect the privacy policy of your users and hence sold their information or allowed access to it unlawfully. So privacy now is very important aspect that you need to pay attention to and make sure that you always stick to any policy that you as the whoever like you're designing the big data strategy or the organizations selling or consuming the data, you need to make sure that you comply to the whatever the terms and condition you have informed your users to. So from technological sides, because like there is a lot of data coming to you, So you have profile data, images, posts, tweets. So, and they are in different formats, different types of data. So these things, when combined together, they can pose a privacy issue. So some of these images might be like some private information in them, and you should not allow access even for processing purposes. So that's just pose another issue when it comes to from a social perspective. Like, does the users allow access? Even like if you're not providing that information to someone, so no one is seeing that private photo, but nevertheless, you are using that for identifying that you went on a trip for the Caribbean. So for you, you have that, you store that on your profile as a private photo. You didn't want to disclose that to anyone. This is like a private trip I went with my friend. I don't want to disclose that to anyone. But nevertheless, if the platform, like let's say here, as an example, the social media platform, use that information to say, hey, you're in the Caribbean, do you want to go here or there? For you, that's a breach of privacy. Like for you, I didn't want anyone to know that. Even like it is not visible, but it's still, that's personal information. I don't want anyone to know about it. I don't want to allow someone to share that information, even on the government level. I don't want anyone to track me and know where I am. For me, that's part of my privacy. So these data sometimes are used, like you're collecting these data, like this information from the people, and then used for marketing research. So I know that you've checked in Sydney, in the city, and I pop up an advertisement telling you that there is a new restaurant, you can drop by, there is this. So for marketing research, this is mostly used. Facebook used to allow access to your data for marketing purposes for third parties, but now they don't. So currently they do marketing, they advertising themselves. So they are posting ads for your profile, but they do not allow access for your data by third parties. So that's some sort of compromise in terms of how they are doing market research. So for targeted advertisement. So, and also like for them on terms of, okay, I know that how fast you're going in terms of, okay, when did you get on the bus, when the bus stopped, when did you get off the bus. So even this information that I can know that, okay, this gives me an indication that more people are going to the city. So I'm using that information for more workflow improvement. So is there anything, is the bus flow in the streets smooth? Do I need to add light rail or something like that? So all this information I can use in order to improve my services. So definitely also when it comes to national security, this is a thing that's like all the data is being used for at some level by national security agencies in order to make sure that there are no breaches of security, there is no incidents. If there is an incident, we can manage that. If there is any malicious parties going in planning something. So all the contents created, all the tweets, all the posts, all the discussions, on some level it is monitored to provide this level of, okay, being up to date if something happened, if there is a riot gonna break out, how we can manage that. So for all this information, it might be like, it is useful for the use case, so incidents can be stopped. But at some level, when you look at what kind of data that's being accessed in order for that to happen, it can pose some privacy issues. Like, okay, this is a private conversation between me and another person. Why would someone snoop in and make some, rely on that to do some marketing or advertisement, or hold me responsible that why did you do this because you mentioned that. So there are some things, there is a fine line between what's privacy and what can be used for, let's say, questionable purposes. So, like for the case when you look at specifically the main big data source that's causing a lot of commotion in that privacy area is social media. So we are unaware that everything that we post, which is tagged public on social media, is not ours anymore. So it belongs to the public. So we will be hold responsible for any photo, any conversation, any public conversation, any public post that we put on the social media for everyone to see. Because in that sense, we cannot argue later on that it's not ours. So all this public information, when gathered together, that, okay, this person, he mentioned on Facebook that he checked in on a restaurant in Sydney, and then on the Twitter he said some interesting things are gonna happen now, be aware, or something like that. So triangulating all this information from this, okay, he checked in here, he threatened someone, or he mentioned something about a riot or something. So triangulating this information, putting them together, it can be deduced that, okay, probably he's doing something dangerous, we should act or do something. So the information publicly available on social media do not belong only to you, because now it's in the public eye. So things like, from the user perspective, if you are let's say the data manager for platform, big social media platform, you need to make sure that, okay, the users are aware of what are the information, what kind of information that they make visible, and if they are actually making that visible, so that, okay, you've made it visible, so you already allowed public interaction to it. So you cannot come later and say, hey, I didn't want people to know this, I didn't want people to know that. So from small data perspective, you need to look at, okay, from the provider side, what are the information, how can I control access to my data? From big data side, so, okay, the data is collected by the organization, by the company, by the social media platform. So what the social media platform can share with third party, what it can use for analytics, advertisement, or market research. So these are the things that you need to, as the data manager, you need to look at, okay, what we are allowed to do, what we are not allowed to do, what we are allowed to share, and vice versa. So different users in that sense and different roles. For the data provider, someone who create the post or post the photo. So I can control is this data sensitive? Do I deem it sensitive, or is this something I want to share with the whole world, that I love Domino's? For me, that's fine for anyone to know. That's public information. It is not sensitive. But on the other hand, if I want people not to follow where I am going and where did I check in, I should control my check-in visibility, making sure that, okay, when I check in to some place, only my friends or only my family can see, something like that. So depending on that, I can control people who are collecting information, whether it is the platform itself or whether someone is scraping the data of the social media platform can collect, and hence make some compensation in terms of privacy. So from data collector point, whether it is the social media platform or the platform that you're posting on, or an entity who's scraping data, if this data scraping is allowed. So you need to make sure that, okay, you're limited to what's deemed unsensitive. So if someone is tagged, this information is private or it's sensitive, you cannot use that for market research. You cannot use that for sharing to other third parties, or you cannot even display in the platform. So this information, like from collector perspective, you need to always respect the rules. And if, let's say, if I'm collecting profile data and there are certain parts deemed sensitive, then in a way or another, we need to make sure that, okay, either I anonymize it or provide synthetic data instead of this information in order to anonymize that person so that they cannot, whoever I share the information with, they cannot know who's that person or what they are doing. So from data miner perspective, so this is a person who's mining the data, the platform for data, and hence whatever there is publicly available, you will be able to collect. Also, there is some level of, okay, are you allowed to mine the data or you're not allowed to mine the data? So there is some issues there. But on the sense of, okay, if there is, you mine the data and there is some protective or sensitive information, you need to also apply some anonymizing or change that, mask that information in order to protect the poster or the data provider from information like privacy breaches. Like whoever, and then there is the decision maker. This is the person or the organization or the entity relying on the data mined from the platform in order to make decision, whether it is a market research. So I want to know how many people purchased this product in the past year. So this also, like, once, because the platform need to anonymize the data, the miner need to anonymize the data, as long as these bits of synthetic data are already there in the data sense, does that make the final data that I have useless? So you also need to, whether if you are in that role as decision maker, and then you are dealing with the data coming to you from social media platform, let's say, as an example, and then there are different stages of anonymizing the data. Does the data that you have now, that you get at the end, is it useful, or is it synthetic data that will render useless for you? You need to make that decision. Is it useful? Is it credible? Or at the end, everything is sensitive and I cannot use anything? So, like, the thing is, like, here is an example of, this is the 2019, it was May. So this is the data breaches that happened in till May 2019. So there are, like you can see here on the records breached, there are for social media, the number of records breached is 2 billion and 200 million records breached on one incident. This is one incident. So there are some, like, this gives you some indication that it's not always, it's like you put your information on social media, but there are some possibilities that these information are breached. So this is not due to only hacking. There are some incidents due to hacking, but there is, like, this is for identity theft. So someone have triangulated all the information from multiple sources and then gathered that information and then was able to steal, like glue together personal identifying information about people and hence do some identity theft. So the information out there on social media, as an example here, for when there is 2 billion and 200 million records breached, that gives you an indication that it's a bit of a messy situation. So all for that, like for these people who have their records is breached, they are at risk of identity theft. Someone can come and pretend that he's you and say, yes, this is me. This is my age. I was born here. I was born there at that date. This is my dad. This is my mom. And then probably like if they can glue enough information about you, they can even do some financial transaction in your behalf, such as calling your bank and say, hey, I forgot my password for my internet banking. Yes, sure, what's your name? This is my name. When is your date of birth? This is my date of birth. What's your address? And all this information were glued together from social media, and voila, he can say that he's you, and your internet banking account password would be reset, and then they can have access for the internet banking and do whatever they want. So there are some issues with data privacy, and specifically with big data and the public data all around there. When they put together, when they are glued together, they can prove some serious issues. So that can bring us to big data security. So big data, like with big data, when you're collecting lots of information, that's causes big amount of sensitive information as well. So banks, they have big amount of sensitive information about you. The government, they have big amount of sensitive information about you. So all these information are sitting somewhere on hopefully some secured repository. And there is for security breaches that if it happens to that platform, you will be affected because this is your sensitive information that's being breached. So personal information, information about me, bank account, transactions, intellectual property, so things that I have, like my Dropbox folder where I put my projects, where I put my papers, where I put my research, trade secrets for organizations, financial information, transactions, balances for information. So like any breach for these data repository cause huge risks, and that's cause for your organization, if you are managing that data repository, cause reputation loss. So if let's say at some point there is a leak of information for the records that you're storing, that will cause a trust for your service to drop because people do not trust you anymore. Financial loss as well, because specifically now with more regulation, there is some regulation that post a fine on the organization that do not properly secure their data, and then the data breach happens. So you need to be aware of that as from data management perspective, how you make sure that, okay, the data we are storing, it is valuable for us to do prediction, to do market research, but at the same time, they are increasing risk. I need to make sure that I secure this data in order to minimize any issues in the future, or if there is a possibility of data breach. So this is like a result of a survey made for some organizations in terms of what's the concerns, what are the challenges managing big data and security. So you can see there are a lot of concerns, a lot of challenges, that's starting with identifying the sensitive data. So a lot of organizations, like this is governmental organizations, for them they are storing data, but they have an issue with identifying what can we deem sensitive versus what can be unsensitive. So there are a lot of things for you as data manager, or like the person responsible for big data strategy in the organization. You need to make sure that, okay, what are the important parts? What are the sensitive parts in the data that we have? How we can make sure we secure them? How we can make sure that breaches do not happen, and hence our organization is affected. So one way of doing that is, if the data that you have, if you have the data you're storing, it's not important for you to know exactly who's that person. So I want to do some market research of what's the popularity of cola in Sydney. So for me, it doesn't matter to know who are the people who have purchased a can of Coke in New South Wales. It doesn't matter. I just want to see the sales. I want to see on a period of time. So the information, the identity of the people is not important. So data anonymization is a key measure that can help you prevent data breaches. So if for you the identity of the people doing the action, the instances of data in your database is not important, anonymizing the data is the right choice. So remove sensitive data from the records so that you still have useful data, but at some level, even if something happens, even if the data breach happens, even if you share that information, it's still okay. It's not gonna be an issue. That's also, unfortunately, not always as easy as it seems. But everyone would do it. Let's remove the sensitive data. Unfortunately, that's not as easy as it seems, because I remember 8 years ago, 6 years ago, something like that, Netflix has made a challenge for whoever come up with an algorithm that's enhanced their recommendation system. So it's a machine AI competition. So they put their anonymized data sets, and they ask people, hey, if you can come up with an algorithm that can improve our recommendation system by this %, then you will win. I remember it was $1 million or something like that. So someone won, everyone was happy till someone was poking around and they find out that using this data along with other sources of data, you can actually de-anonymize that who are the people in the data set. So unfortunately, for them, they were hit with a big lawsuit in that sense, because they were posing that it is completely safe, it's anonymized, but someone find out that they can de-anonymize relying on some external sources. So don't always think that this is the silver bullet for this, because you need to also measure that if there is a possibility for cross-referencing to de-anonymize the data. A very plausible option, but also come at cost, is data encryption. So you would say, okay, why the fuss? I can just encrypt the data and voila, whoever comes to my data repository, it's encrypted, I'm safe. That's definitely the right way of thinking in terms of, okay, let's encrypt, but you need to make sure that, or you need to compensate for the performance issues that's going to happen. Because for your big data, encrypting this huge amount of data and then decrypting on demand to do some queries, that might propose some performance issues. So you need to look at some techniques that can minimize these performance issues, like attributes-based encryption. So it's more fine-grained encryption that can help you on the fly decrypt the data and do any query and then retrieve the data that you want. So data encryption is definitely key, but you need to make sure that you use the right way of according to the technology you're adopting. Access control is definitely also in that sense key. So even for your own data, for your own employees in the organization, you need to make sure that, okay, who can access the data? Who have the privilege to decrypt or encrypt that data, to do inquiries on the data, on what levels they are allowed to access the data. So that's important, because you shouldn't even if you allow access for everyone, then whoever breach into your organization, so even if he breached into the organization as a normal user, he will have the access to your data and the sensitive information. So you need to make sure that proper access control mechanisms are in hand. So only you allow, okay, if you have a group of data scientists in the organization, then they are only the people limited to access the data repository. If there is two-factor authentication you pose on their login, so that as much as possible you secure all the access to the data. So authentication mechanism can help you with that. Definitely also, on top of everything, even if you apply all the measures, you need to make sure that, okay, you have some monitoring capability. So you are monitoring the data, making sure that if something happened, how you recover, how fast you can report that breach, and how you can minimize the effect. So in terms of policy approaches, so when it comes to security as well, so the first thing that comes in handy is that you identify what are the things that you are trying to protect, because sometimes there are some information that's not very sensitive. So rather than you invest into encrypting everything, you can encrypt the bits that's deemed sensitive, or you can mask them or even anonymize them. So isolating the sensitive information, masking the sensitive information, or even like looking at, okay, do I need to adopt additional tooling to monitor specifically these parts, is also can prove useful in that sense. So, and like for this sensitive information, if you are thinking of sharing or allowing access by third party, you need to think from policy perspective and terms and condition perspective. So did you mention in the terms and conditions of your platform that your data can be used for research purposes by XYZ? If yes, then you're safe. If not, and then XYZ have access for research purposes for this data, then you're in a big trouble. So from policy perspective, from the side of terms and condition you have shared with your consumers, with your users, you need to make sure that you always transparent and allow them, notify them of any changes as well. I think like every one of you has at some point received some emails from organizations like in Google, Yahoo, telling you that we have made some changes to our policy because of GDPR. So we'll talk about GDPR in a bit, but that sense, because it's more a policy changes in Europe, that's how organizations should protect their data. So every organizations operating partially in Europe, they had to comply to these changes and change their terms and conditions accordingly. So governance and frameworks, like when it comes to security, there are well-known frameworks for general security. So ISO 27001 is a well-known security best standard recommendations that organizations follow for their information security within the organization. Unfortunately, there is no specific big data governance and frameworks specifically tackling issues with big data and privacy, but hopefully like within the years, once the recognition that it's not as straightforward as like or enterprise data or small data sets to manage, the frameworks will be developed for the for other organizations. Because like here, the main challenge is because there is variety and different kind of data, different kind of how they are managed, how they are stored, propose additional challenges for security as well. So general good practices. So whenever you're like if you're relying on cloud-based solutions for whether data storage or data processing, so maybe you're storing the data on site but processing like on the cloud, you need to do some vetting, see what they are offering in their terms and conditions, in their policy, in their SLA, what they are saying, what's their responsibility for the data protection and data security. So when it comes to internally, definitely adopting some adequate access control policies, who can access what, on what level, how they authenticate themselves, two-factor authentication, probably best practice, and that's with sensitive data rather than a single factor.